Hello everyone, this is the Science Chef. In this video, we'll be learning how to calculate the hydrogen and hydroxide ions when you're given the pH and how to calculate the pH of a titration mixture. Go nowhere and we'll be right back after this break. In our last tutorial, we learned about pH and indicators and how to calculate the pH and pOH of a solution when you are given its concentration. If you'd like to learn more about this, check the link in the description. To calculate the pH of a titration mixture, you must first of all understand the concept of the concentrations of the acid and alkali. So the first part of this lesson is to learn how to calculate the concentrations of solutions. There are two types of concentrations, namely mass concentration or concentration in grams per dm cube and molar concentration or concentration in moles per dm cube. Mass concentration is defined as the mass of a substance in grams present in 1 dm cube of water, and it is mathematically represented as mass in grams divided by volume in dm cube, or mass in grams times 1000 divided by volume in cm cube, given that 1000 cm cube equals to 1 dm cube. Similarly, molar concentration is the amount of a substance present in 1 dm cube of water and mathematically represented as moles divided by volume in dm cube, or moles times 1000 divided by volumes in cm cube. Both concentration terms are related by the equation mass concentration equals to molar concentration times molar mass, which can be rewritten as molar concentration equals to mass concentration divided by molar mass. If we substitute equation 2 into equation 6, it becomes molar concentration equals to mass divided by molar mass times 1000 divided by volume in cm cube. After obtaining the concentration in moles per dm cube, we can then substitute it into the pH or pH formula as necessary. Let's solve some examples. Example 1. During the titration experiment, 50 cm cube of 0.1 molar HCl was titrated against 20 cm cube of 0.1 molar sodium hydroxide. Calculate the pH, pOH, hydrogen ions concentration, and hydroxide ions concentration of the mixture. To solve this problem, first write the equation of reaction between sodium hydroxide and hydrochloric acid to produce sodium chloride and water. Next, calculate the number of moles of each reactant from the parameters provided by modifying the formula from equation 3. That is, number of moles equals to concentration in moles per dm cube times volume in dm cube, which gives us 0.002 mole for sodium hydroxide and 0.005 mole for hydrochloric acid. From the equation of reaction, the mole ratio of sodium hydroxide to hydrochloric acid is 1:1, and from the calculated number of moles of the acid and base, 0.002 moles of the hydrochloric acid is required to completely neutralize the sodium hydroxide solution. We can then see that the hydrochloric acid is in excess by 0.003 mole. From this, we can calculate the concentration of the titration mixture by dividing the excess number of moles by the volume of the solution. The volume of the solution is obtained by adding the volumes of the acid and base used in the titration, and that gives us 70 cm cube or 0.07 dm cube. Hence, the concentration of the titration mixture in moles per dm cube is 0.0429 moles per dm cube. Given that the titration mixture was acidic due to the excess hydrochloric acid, it means that the hydrogen ions concentration is 0.0429 moles per dm cube. To get the hydroxide ion, we use the equation for the ionic product of water and then make hydroxide ions concentration the subject of formula and evaluate to obtain 2.33 times 10 raised to the power minus 13 moles per dm cube. To calculate the pH, insert the calculated hydrogen ions concentration of the titration mixture into the pH formula and evaluate to obtain approximately 1.37. To calculate the pOH, subtract the pH value from 14 to obtain 12.63. Example 2. What is the pH of the titration mixture obtained when 21.50 cm cube of 0.1 molar H2SO4 was titrated against 25 cm cube of 0.2 molar pOH. Just like the previous question, we write the equation of reaction between sulfuric acid and potassium hydroxide to form potassium sulfate and water. From the balance equation of reaction, the mole ratio of the acid to base is 1:2. Next, we calculate the number of moles of the sulfuric acid and potassium hydroxide as 0.00215 mole and 0.005 mole respectively. From the mole ratio, we can see that the potassium hydroxide is in excess because if 1 mole of the acid is completely neutralized by 2 moles of the base, then 0.00215 mole of the acid will be completely neutralized by 0.0043 mole of the base. But since we have more than that amount of the base in the titration mixture, it means that it is in excess by about 0.0007 mole. The volume of the titration solution is 46.50 cm3 or 0.0465 dm3, obtained by adding the volume of the sulfuric acid and the volume of the potassium hydroxide. Hence, from the number of moles of the excess base in the titration mixture and the volume of the mixture, we can calculate its concentration as 0.0151 mole per dm3. Being an alkaline solution, this concentration is the value of the hydroxide ions concentration. To obtain the hydrogen ions concentration, divide 10 raised to the power minus 14 by the pOH, and that gives us about 6.62 times 10 raised to the power minus 13 mole per dm3. Substitute the hydrogen ions concentration value into the pH formula and evaluate to obtain approximately 12.18 as the pH of the titration mixture. You may need to watch our last tutorial on pH and indicators to understand how we make use of the laws of logarithm in solving pH problems. Example 3. Calculate 1. The number of moles, 2. The amount in grams of HCl that must be added to 200 cm3 of water to give a solution of pH 1.70. To calculate the number of moles, we must first calculate the hydrogen ions concentration from the pH. This will give us the concentration of the solution. So, let's insert 1.7 in the pH formula and then find the antilog of minus 1.7. We would obtain the hydrogen ions concentration to be 0.0200 mole per dm3. To get the number of moles, multiply this concentration by 0.2 dm3, which is the given 200 cm3 volume converted to dm3. This will give us 0.004 mole. Finally, to calculate the amount in grams, multiply the calculated number of moles by 36.5 grams per mole, the molar mass of hydrochloric acid, and this gives us 0.146 grams. In our next tutorial, we'll be learning about salts, their definitions and types. Don't forget to subscribe to our channel and turn on your notification bell to get notified when we publish the video. Till I come your way again, stay on the right side.